what we're going to achieve in this 1 hour session. Okay, so quickly let's start understanding what is big data. So the biggest question I keep hearing from majority of the audience, whomever I interact with, so the biggest confusion for the newcomers is whether big data is a technology, or is it a term, or is it a hype, or is it a buzzword kind of a situation. So definitely big data is not a technology. It is just a term which used to define volume of the data, as simple as that. So it is not a technology, it is not a platform, or it is not a solution. So it's just a term used to refer the volume of the data in very simple and in very straightforward definition of what it could be all about. Okay, so a little bit more digging into the definition of it. So big data could be collection of large data sets. When I say large data sets, it could be contextual. So a large data set could be terabytes or petabytes of data. So that's what I would mean as lots of data or large data sets. And moreover, when you have this more complex data structures within that large data sets, so it becomes really difficult to handle or manage to process that kind of complex and huge volumes of data using conventional RDBMS technologies and conventional data warehousing platforms. So that's when the big data technologies or the big data platforms comes into rescue to help the processing of volume and the complex data types or the complex data structures. So some of the challenges what you would usually find in the big data scenarios is the challenge is to capture the huge volumes of data would be one of the most challenging things. So when I say capture, so you have to aggregate all the data from different sources and retain it for a longer period of time to get any business insights or to run into any business reports out of that data. And also if you have to do any sorts of transformation or you have to cleanse that data or you have to normalize that data on a big scale, it really becomes challenging for you to do that kind of job on a conventional approaches. And also storing it, sharing it, that kind of data, and on top of it, if you have to do analytics, so that's some of the challenges what you would usually come across. So these are the challenges what usually you would find, so that people came out with different approaches to handle big data and to process big data, store big data, and manage big data in a different ways. So all said, so big data also is not only related to Hadoop or any specific technology. So it is a term. So there are a lot of technologies, lot of platforms, lot of solutions being offered as a big data solution. So big data always does not map to Hadoop or Hadoop is not always tied up to big data. So that's another confusion what people come up with and say, hey, big data is all Hadoop. So no, that's not the case. So Hadoop is a framework or a platform which can handle big data problems or big data kind of a, challenges. So apart from Hadoop, there are different technologies, just like NoSQL technologies like Cassandra or any other NoSQL storage solution or cloud. All of them are capable of handling big data. So I hope that gets cleared so that we don't get into the confusion of what exactly the big data is all about, or whether it is always tied to Hadoop or not. So straightforward, it's not. Okay, so a little bit more digging into big data. So why big data is gaining momentum in the recent years, or why is it being exploded into a lot of discussions and a lot of forums, and why it has gained momentum in the last decade or so? Few reasons. So digitization growth. So the big data started gaining momentum because of a lot of organizations got the capability of digitizing their platforms and digitizing their solutions or systems, which eventually started generating a lot of data. So the moment you start generating a lot of data, you'll see an exponential data growth in the internet or on the IT sectors or on, say, any domain for that matter. So the biggest thing what you would notice in the recent decade or so is the digitization, which has triggered the data growth, and the data what has been emitting was so complex and unstructured. So on the slide you would notice, so the relational or the structured data growth was very saturated, and it was very normalized kind of a growth. When it comes to the digitized, unstructured or complex data, you would see tenfolds of exponential growth which happened in the recent years, which was a drastic change. So people started to explore the data what they are aggregating or the data what they are emitting. So, and when you have the affordability of the storage solutions and the computing solutions, which was not possible in recent times, say for example a decade back, we could not afford a 1 petabyte storage solution that easily. So very few organizations or research organizations or government organizations were able to compile or build up that kind of a scale, massive scale of storage. But today, petabyte scale is accessible or affordable even to a smaller to a medium-sized organizations who could spend, say, for example, a few thousands of dollars. They could afford easily a petabyte storage for storing their data. Okay, so that was not the case few years back. So the affordability of the storage and the computing has enabled the data growth and the data digitization aspects of it. And moreover, the business now wants to leverage the data being generated by analyzing the data and getting insights into that data and try to drive more business revenue for their organizations. So these are the few things what has really got big data into limelight. So just rough numbers. So you would find roughly around 3 hexabytes of information or digital data which is lying in the computers today, as of today. It is just a rough number. It is not the absolute or exact value. So I'm just making a rough guess, around 3 hexabytes. And also a few numbers like the digital universe started to grow exponentially by 60 to 70% with few hundreds of thousands of petabytes, and it is expected to grow to zettabytes in the near future, or it would have already reached to maybe even 2 or 3 zettabytes in the near future. It shouldn't be a surprise. So just a quick numbers on how big data is playing and how the big data is being transforming the world today. So most of you, those who are on the Facebook analyzes and stores more than 50 petabytes of user-generated data. It's just a rough number, and companies like Akamai, they have more than 100 million events which has to be aggregated and which has to be analyzed to target better revenue management using their ad management. So there are different combinations of data management, data analytics which companies used to do. So I'm just giving some numbers to just get the feel of it. So companies like Google, they have to index the entire web over the period of time. So they have to go and scan each and every web page, analyze the document, store the TF-IDF weight factors, and then index it, rank it. And it is a huge data volume for us to crunch on periodic basis. So Google does it again in petabytes or in kind of big volume. So these are all the kind of scenarios where you will come across big data where it has been exploding in recent times. Okay, so not limiting the conversation to certain aspects like Google or companies like Facebook kind of a thing. So before jumping on to other scenarios, the biggest thing what we have to underline here is, so the world's technology capability of adapting capacity of computing or storage has roughly doubled in the last year and a half or last couple of years. So that is the primary reason where you would see, or the standard thumb rule says every 2 years the organization's capability or the feasibility of adapting technology storage or technology computing increases by roughly around 100 to 120%. So that's one of the reasons why you would see a big data jump happening all of a sudden. Okay, so it should not be also treated that big data is always related to companies like Facebooks of the world or Google. So there are a lot of domains where you can aggregate a lot of big data and analyze that big data to drive some useful business benefit or real value out of it. One such example is, say for example, if there are a lot of hospitals who want to track and monitor the patient's historical diseases, historical medications, and try to keep all those historical records and analyze it over a period of time to make recommendations or treatments for those patients who could be predicted for any abnormalities even before it could happen. So those are the huge challenges for the healthcare sector, where people have to keep all the records for, say, 20 to 30 years when a patient gets enrolled, and keep analyzing those records over the period of time and recommend right treatment so that they avoid costly hospitalization kind of a scenario. So it also helps the insurance companies to go ahead and make the right investment or the right insurance policies to the patients. So this could be a lot of scenarios where the healthcare sector can also be leveraged. So just a quick example of how we could also do that in healthcare sector. Okay, so when it comes to Amazon, so most of you would have already used Amazon for shopping, buying such stuff. So Amazon banks on the huge amount of customers interaction, customers behavior, and what they have done in the past. They collect all this information, they aggregate all this information over the period of time, and they make the right recommendations or the right choices for you to choose based on your historical behavior or based on your similar user behavior on similar products. So there are different things like people like Amazon practice. So they store all the interactions between customer to customer relationship and customer to product relationship and make the right recommendations so that you could get a better choice of what similar things has been done by a similar user. So they predict the user behavior and make the right recommendations to the users. To store all the user interactions and to make the right recommendations, you need a huge scale of data volume storage, which has to be persisted across users and across all the millions of products they have in their store, and then go ahead and run, say, analytics on top of it and make the right recommendation. So Amazon uses all the big data storage and also the analytics big time so that you could get right recommendations and right choices for your shopping experience. Okay, so another example, I'm just trying to cover a few real world scenarios so that you could get a sense of where people are using big data and analytics. So Netflix again uses big data Hadoop data warehousing platform, which is a petabyte scale again. So Netflix has all this information which is gathered from the streaming events or from all the Netflix enabled devices, the televisions, laptops, and all the mobile devices on a hourly basis. They capture all these information and they store all this information on different storages like S3, Cloud, and Cassandra. All these are all the big data solutions, and then they run multiple clusters of analytical platforms like Hadoop. They run elastic MapReduce clusters on top of the S3 storage, and they provide a lot of insights into the business reporting, and they make a lot of business interactive queries for all their applications. So they have multiple EMR clusters, which is like 500 plus node kind of clusters which Netflix currently leverages or Netflix currently uses, and some brief stats of how Netflix has streamed the Avatar movie reported to be storing all that information required to stream, and also how big data solution is required to render the Avatar 3D CGI graphics. So just a very brief introduction about some of these things. Okay, so quickly getting into some of the formal definitions of what big data is all about. So IBM has this formal definition defined in 3 or 4 V's, or in some cases more than 3 or 4 V's. So we'll stick to 3 V's. So big data can always be referred to as volumes. So when you have massive volumes of terabytes or petabytes of information, that can qualify to be a big data kind of a scenario. So sometimes it's not always required that it has to be a volume. So what IBM says is it also has to be velocity. Sometimes in some scenarios, processing a huge volume of data in say 20 minutes may be too late, right? To get some insights to a mission critical application, 20 minutes may be too late. So velocity is also a key factor in deciding a big data platform and a big data solution in most of the cases. So when it comes to variety, so there can be variety of content. It is not always it has to be text-based content or a HTML file content to index the web kind of a thing. So your solution may change based on your big data, whether it is video content or images or sensor data or web logs or audio files. So it has to be capable of handling variety of data. So if you have a big data which is covering all the 3 ways, 3 V's, and also your solution is capable of handling all different aspects of these 3 V's, then it is referred to as a big data solution. So also there is another V, sometimes people call it as veracity. So the 4th V is veracity. People try to refer, it should have some sort of support to have hybrid integration models. Say for example, it should be able to integrate with the databases or any other conventional technologies so that it could offer the hybrid kind of a solution or a hybrid kind of a platform. So put all together these 3 V's, you can define a big data solution by identifying these characters or identifying these attributes of the solution. Okay, so if you have any confusions, follow these 3 or 4 V's and see whether this falls into this big data tag or not. So you could pick up any solution and see if it falls into all these 4 categories, and you could define or classify this as a big data solution. So as simple as that. So I could use this as a technique to identify whether this is a real big data solution or not. Okay,